So I'm just going to record this video to go over just some information about this Arachnid toolhead and gantry assembly mod, as well as some tips for if you want to make it yourself. So yeah, this is the toolhead for the Arachnid mod. It's called that because it kind of looks like a spider with the fins of the fan on the bottom. Anyway, the main differences between this and the stock, like the regular V100 toolhead, is first of all, is the part cooling is fully auxiliary. So all of the cooling is shot in from auxiliary fans from the side, and then these air ducts on the side of the toolhead kind of just direct air downwards towards the print. It's surprisingly effective if you just put the fans on and just hold your hand like 10 centimeters below the fan head. It's surprising how much air is actually able to be pushed down. This is of course inspired by the 24/7 printing Voron Zero, which also has auxiliary part cooling. This of course just saves weight. You don't have to have any onboard fans. I think it's around 80 grams that those fans would weigh. The next thing is with the X rods. So it uses an 8mm on the bottom and a 6mm on top, and it's using the long bearing variants for both. So the top is, I think, 35mm wide, the bottom is 45mm wide. This is of course more heavy than if you were to use the short length versions of these bearings, but I think that the added stability is still pretty good. The added stability is very good, and the overall weight, you know, it is increased, but it's still relatively light. This toolhead, for the version of the toolhead that I'm holding right now, this weighs 170 grams. But that could increase or significantly even decrease depending on your material selection, your slicer settings for the printed parts, as well as your hardware choices. Like if you wanted to use titanium or PEEK screws, that could save weight. If you wanted to use a shorter 8mm bearing, you could also do that. If you want to be a little bit more sparse with the infill, you could also do that. So yeah, I'd say around 150 to 180 is the realistic range for weights for just the toolhead. For the whole assembly, it's around 450 grams. It's much lighter than the standard for the 100, but compared to builds like 24/7 printing's Voron Zero, it's still significantly heavier than that. But I think that just because of the build volume of this printer and the use of two rods for the x-axis, that getting lower than that without compromising on stiffness and strength it's going to be pretty difficult. Yeah, some more things about the toolhead. The entire it's only 3 printed parts for the toolhead. The skirt at the bottom, that's basically just the fan ducts. Then the rod carriage and the hot end holder. This is all printed as one piece. This would be 3 separate printed pieces that are all screwed together in the standard 100 build. But to save weight and also increase stiffness a little bit, this is all just printed as one part. And then of course there's like the hot end clamp, which is almost the same as the standard one. It's just a little bit skinnier, so it can fit between these 2 posts. It's compatible only with the Rapido hot end. Yes. And then just a standard 4010 fan for hot end cooling. Yeah, so a couple of considerations to make when making the toolhead is, first of all, print settings. For printing the skirt, you don't want to use any supports at all, no supports, and also no brim. The STL has little mouse ears included to improve adhesion. Using those mouse ears, I've never had any problems with adhesion or warping or anything like that, and this is printed in ASA. and on an open frame printer on the Bambu Lab A1, and I had no issues with that. You can get away with printing this out of ASA instead of PLA because this the skirt doesn't actually provide any stiffness to the construction. It doesn't actually touch the hot end really, so yeah, it still feels pretty stiff considering it is ASA, but this doesn't actually need to be stiff. This you could probably print this out of TPU and it wouldn't have any real difference, but I recommend printing this part out of ASA because ASA is less dense than PLA, so the same settings you can get much lighter parts. Okay, not much lighter, but lighter parts. The main rod carriage as well as the hot end clamp, you're going to want to print these out of just regular PLA. You're going to really want that stiffness because all of the stiffness comes from this one, from the rod carriage. It really does need to be stiff. Also, I recommend printing hot because layered adhesion is going to be pretty important. These posts, as well as this section here, is very prone to breaking when removing supports and also installing if your layer adhesion is not good. I have actually tried printing the carriage in carbon fiber PLA, and while the stiffness is great, I just wasn't, even when printing 20-30 degrees higher than recommended, I still just could not get layer adhesion to be good, printing out of a dryer and everything. Because the stresses this would go through when accelerating very fast, I think would be high enough that if your layer adhesion isn't, great, it could cause some issues, cause some cracking. Also, whenever you're tensioning anything in like screws or heated inserts, kind of the more brittle the materials are, the more likely it is to just kind of break, either separate layers or just detach the heated inserts. This is printed out of marble PLA, but you're actually probably just better off using regular PLA. Marble PLA, while not quite as difficult as CF PLA, does have some kind of brittleness and layer adhesion issues, so I ended up printing this quite hot. Yeah, so for supports, you will need supports for the carriage. This is just a previous version, not the exact same as the final version, but close enough. You're going to want supports here on the bottom. I'd use manual supports if you can. Supports there. You're going to want some supports underneath these two posts. And then you're going to also want supports on this underside here, inside there. You're going to want to make sure that your support settings are pretty dialed in, because if your support interface is dodgy and there's just anything sticking out, it's going to be very, very hard to install the skirt, and it's also going to require a lot of post-processing. Yeah, that's pretty much it. I printed this with 20% gyroid infill, four perimeters, 3 top and bottom layers with layer height of 0.24 millimeters. The way you're going to put these together, you're first actually going to need heated inserts, 2 normal positioning for the hot end clamp, and then also you're going to have to get heated inserts on the inside over here. These are a little tricky to install. I'll show you how to do that right now. So this is one that I haven't put the inserts into yet. You're going to need your soldering iron, a long M3 screw, heated inserts, and ideally some pair of little pliers. Just going to hold the insert in that gap, and you're just going to thread the screw right into the insert. It's a little fiddly. And you're just going to, with your finger, put pressure on there so it's in the hole. And then I don't have my soldering iron on me right now, but you just basically want to hold the very, very tip of your iron against the side of the brass of the insert, and then just continue putting pressure on it with your finger and holding the soldering iron to it until it reaches your desired depth, at which point you just hold it in that position as flat as you can until the plastic is cooled enough to then just unscrew the screw. It's not going to look very pretty because it's kind of hard to get like a flat object to really push it down. But I was able to do this easily enough. Yeah, that's probably the most fiddly part of this build. You'll probably end up melting some plastic around here. It won't look very sightly, but it should be fine. Then once your inserts are installed, to install this guy, you kind of want to hook in one side. You're just gonna press this arm into that gap, and then once one side is in, you have to kind of bend the other side out, lift it up, and then push that in as well. It does snap together pretty well. If your printer is not calibrated very well, or there's some like support interface or something like that, it might be difficult to insert all the way. These do need to fit. Do need to fit very well, very flush. So you're probably going to end up having to, just with a razor blade or something like that, just kind of scrape away extra PLA, because if this is just even a little bit off, you won't be able to screw it in. So yeah, once that's in, it's just a matter of getting your 4010 fan, putting it just right on the front. These match the screws, and then you just two M3 screws in the bottom. I believe they're 25mm screws. And then at the top, same 25. There are no heated inserts for the top. For the top, you just really have to use an M3 bolt. Just make sure to tighten everything down pretty well, and you're good to go. It's pretty light. And one important thing you cannot forget to do is, for the Rapido, you have to wrap around the first inch of the thermistor cable. You have to wrap it with something insulating. In my case, I use like an aluminium fiberglass tape. This is because the air from the hot end fan will end up actually blowing directly on the end of the thermistor, since there's no barrier, there's no wall to stop that airflow. And what it will do is Clipper can't read your temperatures accurately. So when printing hot, Clippy will shut down because of thermistor heating at unexpected rates. So make sure to do that, otherwise you will have some issues. Another thing that I did that is kind of hard to see, because it's kind of hard to see right now, but for the ultra high flow hot end, there's even when it's fully tightened, there's just a very, very thin gap between the high flow adapter, the nozzle, and like the main heating area. And you want to fill that. For optimal heat conductivity. In my case, I just got like some copper wire. I coated it in some thermal grease and just wrapped it around, filling in that gap slightly. That should just keep temperatures more consistent and maybe even increase flow just a little bit. So that's basically it for the actual tool head. Now we'll move on to the gantry. So these are a modified version of the Patreon exclusive lightweight gantry. I printed these out of carbon fiber PLA because layered adhesion isn't as important on this part, and the extra stiffness is very much welcome. So the main differences between this and the standard lightweight gantry is, first of all, I just kind of thickened some parts, like I thickened both these walls, and also just kind of shaved various parts of it down where I found it unnecessary, and also just increase the size of the holes for these posts because I was having some difficulty putting them in. But the main thing you'll notice is that at the bottom there's no screw-on panel to connect the bearings. In fact, there's not even any holes for the inserts, those are removed. Instead, these are meant to have the bearings, the long 8mm bearings, just glued straight in there. I use JB Weld. It's perfectly strong enough. And yeah, I had some initial concerns that if there wasn't kind of pressure along the outside of the bearing that it wouldn't quite be stiff or stable enough. And that probably is true to an extent, but maybe just because of the overall reduced weight, I haven't actually noticed any issues because of this, and it saves a good amount of weight as well. Yeah, so just those are glued straight in. It's a little tricky to glue these in, because if they're even just a little bit tilted, once the resin's cured, you just have to buy new bearings, I guess. So what you really want to do is, after you stick them on with the JB Weld, use a lot. You just kind of want to line them up. Just have something flat. I just used a block of aluminium, flat on top, and then I just with some clamps just clamped it down to my table to hold them completely flat and flush with the gantry until they're cured. You could also probably just do this by loosely putting it inside a bench vise, just holding it together, but the important thing is you just really want to hold these stably, because if they cure crooked, that's just suboptimal. You could probably make it work if it's not too bad, but you really want to make sure these are nice and flat. Yeah, and the last thing about these gantries, where some of the weight savings come, is instead of using metal washers, I used plastic washers. Here is one actually. I got these from Egos. You can order them on their website. I think they're like €1 a piece, which is pretty expensive. These have a very low coefficient of friction, of course lighter than metal, and they are all uniformly shaped, so you don't have to do that thing where you measure each washer one by one. Yeah, these just come at the right height. But honestly, the washers don't need to be especially strong or temperature resistant, I don't think. So you could get away with just printing washers yourself. Just print a set of M5 washers and that will be good enough, I reckon. They use the standard bearings. I have tried using like plastic bearings in the past. I have a number of attempts of gantries using either drylins or plastic flange bearings for the gantry, and while that does save a stupid amount of weight, at very high accelerations it just doesn't cut it. The moment they get any temperature in them at all, they just start to stutter and just not sound so nice. So you're just going to want to use regular bearings. And then instead of using a super heavy M5 steel bolt, I instead, just on a lathe at work, I just machined these little aluminium posts, like these aluminium dowels. They are completely hollow and have M3 threads on the inside. And yeah, they work perfectly. They save a good amount of weight. This is a very good way to save weight in any 100 build, is to use some kind of aluminium post instead of the M5 bolts. I think you could also use PEEK, but that's a lot more expensive than just aluminium. If you don't have access to a lathe, if you do, these are quite simple to make, but if you don't have access to a lathe, you can order these little aluminium spacers on Amazon. These are made for like lightweight drones. Not sure exactly how they're used. These also are hollow and come with M3 threads on the inside. But about these though, these do not come at the correct tolerances. These are around 500ths to a tenth plus, when for these bearings you really need them to be like a tenth below, otherwise they won't go in the bearings. So if you do decide to order these, what I recommend is just put them in a drill or a Dremel and just spin it and hold some sandpaper to it until it reaches like a tenth below or something like that, and then it should work fine. But these, if you do decide to use these from Amazon, you will have to post-process them slightly. They are not ready to be put into bearings out of the box. Yeah, so that's the two main gantry parts. I already said the X rods are 6mm and 8mm. I have tried a few different combinations. I've tried both 6mm steel. I've even tried involving one of the rods being aluminium. Those things did significantly save weight, and they worked, but once getting high accelerations, they're just really not optimal. Just the vibrations just absolutely kill them. You really, I don't think you can go any lower than this. This is about the least amount of weight you can have on your x-axis before things just start to get way too flexy. The last thing for this build is the auxiliary ducts. They're not really coming out very well on camera, but these are just printed in place. They slot directly on the frame. You have to remove 2 of these screws from the inside, and then you just screw it on. You can see the holes there. And then in the bottom, it just slots in these 120mm radial fans. I'm not using a adhesive or anything. They just press fit in there, and they stay pretty well held in place. You might want to just put some white tape around the edges just to seal it up a little bit, but they work very well. So if you stayed to the end, thanks for watching. I really hope that I see some other people make this build. I've gone through multiple prototypes of this, probably half a dozen, with just various hardware combinations, various designs of printed parts. And this is, I think, the first version where I feel comfortable sharing it, where I think that you will see decent improvements without too much tinkering. I'm going to be installing this in my printer in the next couple days, and I think I'll just record another video where I'm going to try and do some fast printing. Currently, my Benchy record is just under 6 minutes, but I'm looking to try and do some faster times with this. Yeah. If you have any questions about this build or any of the parts, please let me know. Just send me a message on Discord. And yeah, please just let me know your feedback. I'd like to... This is not going to be the final version. I will just slowly be making some changes to this over the next few weeks. I'll just keep on updating the printables page. Yeah, that's about it. Thanks for watching.